to the identification of functional groups, which we missed earlier, we are going to identify functional groups in different types of molecules, different type of complex molecules. Okay, so the first structure, we have our first structure as this. How many types of functional groups are there? We can say that this is a long alkane chain. There is no double bond, no triple bond, so these are the long alkane chains. So these are the alkanes. Okay, and another type of functional group we have is C, O and O, like C, O and O. It is like this, and to O there is CH2 here and AR chain like this. So this group is actually called as an ester, where we have COO, ठीक है, C double O. So this is an ester. So we have ester and alkanes here. Now coming to the next, we have a functional group like this, and it is aromatic. Okay, it's an aromatic ring, and we have seen here NH2. Okay, NH2. We have learned a functional group called amines. No? So amine will have NH2, but the second thing which we should also know, which type of amine is this. We have learned three type of amines: primary, secondary and tertiary. Primary amines are those which have only one R group attached, secondary which has two R group attached, and tertiary which has three R groups attached. So here we are going to write it in a simpler way to recognize its type. It is actually like this. I'm going to write it in an open form. There is a CH2 and there is a ring. No? Okay, so the NH2 is attached to only one carbon chain, so it's a primary amine. Okay, it's a primary amine. Now coming to the next structure, which is this. In it we have NH3, CO, but you can see that CO is not attached like this here. Here is NH, so you cannot count it as CO. You must count it as CONH, and it's an amide. Okay, it's an amide. It was amine, the NH2 type, or it's an amide. When NH is attached to CO, that functional group will be called as amide. And the another is COO. You have seen, and you can get confused between both of these, that it is also COO. Okay, and that O is attached to an R group. I have mentioned this. It's an ester then, if that O is attached to an R group. No? So, but when your O is negatively charged here, this O is not attached to any R group, so it will not be an ester, but it is an acid, carboxylic acid. Okay, there are two consequences. You can be given COO negative, or you can be given as COO NH. Carboxylic acid can be represented as both of these, a charge on oxygen and a H with oxygen, so it will be a carboxylic acid. Okay, the next molecule is this. अच्छा, एक ये भी है, it is an amine. Okay, tertiary amine. N is attached to three different R groups, so it's a tertiary amine. Which group is this? COO, and O is attached to a carbon atom. so it's an ester again. Okay, so we have done with it, the identification of different types of molecules. And now coming to the next structure. Here is our next structure. It's quite long, so start from here. Okay, you can start from anywhere, but I am starting from here. Okay, it has OH attached, and we know that OH attached to any type of carbon, it will be called as alcohol. So we have alcohol here. It's an alcohol too, okay, because OH is attached to an R group or any carbon, so it's an alcohol too. There is an O, okay. O is attached to two different carbons. It's an ether. Here's an O again, and which is attached to two different carbons. It's an ether again. It's an alcohol again. It's an ether attached to two different carbons. It's an ether. It's an alcohol. It's an ether. This O is attached to two different carbons. This is an ether, obviously. There is a different functional group called ester here, COO, okay, and the COO is attached to two different carbons, so it's an ester, not an acid. Okay, now another functional group we have, it's an alcohol, ether. There's a different functional group here called an COOH, which is an acid, carboxylic acid. Okay, 4 types of functional groups we have recognized. The next, ether, alcohol, ether, acid. Okay, we have only 4 types of functional groups here. Not an alkene, not an alkane, not any other type, or not aldehyde or ketone as well, but we have only 4 types of functional groups here. So in the last lecture we have done alkenes nomenclature according to the IUPAC system, in which we have done the nomenclature from structures to names, and now we are going to name them from names to the structure. Basically we have here 2-methyl 2-propene. Okay, so 2-propene. When we go from name to structure, we know that we first look at this end part. Okay, it's prop. It means it has 3 carbons. So I would write like this: 1, 2, and 3. Number them. It's an ene. It's an alkene. So obviously, at which position? We will see here just before it. At 2 position, ene is present. So if 2 is written here, it doesn't mean that the double bond will be in between 1 and 2, but it should be in between 2 and 3, because we always write the number for alkene here, which is actually the least. Okay, so I will write the double bond here. Okay, it's a double bond here. Okay, so now 2-methyl. It means that at the second position a methyl is present. So I will write a carbon here as this. Okay, so there are double bond between 2 and 3 and a methyl group at the position 2, and there are 3 carbon atoms in total in our longest chain. Okay, so that is our the first structure, from name to the structure. Okay, now coming to the second structure, we have pent. Okay, and pent means 5, so I will make 1, 2, 3, 4, and 5. Okay, I will number them: 1, 2, 3, 4 and 5. And now ene, at which position? 1. Okay, so there is an alkene which is present in between 1 and 2. Okay, double bond here. And coming to the next portion, dimethyl, it means 2 methyl branches are present, which is composed of 1 carbon, which meth represents 1 carbon atom. So there are 2 methyl groups present at which position? 2 and 4. So I will write methyl groups here and here. So it will be our final structure. Coming to the next structure, 1,3-butadiene. So first of all, we will focus over the but. It means 4 in chemistry. 1, 2, 3 and 4. Okay, I will number them first. It's the method or criteria of converting a name into a structure. Okay, but. Okay, but. Diene. In the previous examples we have seen that there is only ene written here, but here's the di is also involved in it. Diene, it means 2 alkenes. Okay, at which position? There must be 2 positions, 1 and 3. It means for this one we will write an alkene between 1 and 2. Okay, and for this position we will write an alkene between 3 and 4. You must take care of it, that the positions in case of alkenes. Coming to this 2,5-heptadiene. So hept means 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 and 7. Okay, so again a diene at which positions? 2 and 5. So for 2, between 2 and 3 an alkene, and the second alkene will be in between 5 and 6. 5 and 6. Okay, now coming to the next molecule, 1,3,5-hexatriene. What is the name? Just forget it, just focus on this thing first. Hexa means 6. 1, 2, 3, 4, 5, 6. Okay, tri, it's not a di here, it's a tri again. Means 3 ene, alkene, means at which position? 1, 3 and 5. For 1 I will write an alkene between 1 and 2. For 3 I will write an alkene between 3 and 4. For 5 I will write an alkene between 5 and 6. Okay, 2-pentene. Pent means 5. There are 5 carbons here. 2, 3, 4 and 5. Ene, only 1 ene here, and at which position? 2. So I will write a functional group called alkene between 2 and 3. Okay, so that's the nomenclature of alkenes from name to the structure. Okay, alcohols are basically in organic chemistry you see like this, any alkyl chain attached to OH. Okay, so the OH is actually the representation or identification of an alcohol compound. Okay, so whenever you see an OH directly attached with an alkyl chain, it can be like this. It's an OH group directly attached to any carbon chain. It's an OH directly attached to any carbon chain, so it will be an alcohol. So all these compounds are alcohols here. So the next important thing is this, in naming alcohols we actually use the ol at the end. Likewise we used ane, ane, ane in case of alkanes, ene for alkenes, and now we are using ol at the end of the names. We will see that. So coming to the first molecule, our first rule from structure to names is to select the longest chain, okay, longest carbon chain. So here obviously there is only one carbon chain here, so we will select it. It's our longest carbon chain. Now we will number it from there or there. From obviously here we will start our numbering, because OH is really near to this end. 1, 2, 3 and 4. Okay, now we will see at which position our OH is attached. So OH is attached to the second position. So when you are going to name, you will use for the position 2 dash, how many carbon atoms in the longest chain? 4. So you will write bute, okay, butane, and just because of this OH you will use ol, 2-butanol, okay, it's a 2-butanol. Now in case of this, our longest chain obviously is this. We will number it 1, 2, 3 and 4, not from there but from there. 1, 2, 3 and 4. Again we have OH at second position, so we will write 4 carbon atoms in our longest chain, so we will again write butane, not E, okay, E is actually excluded here. Butanol, okay, that is the criteria. Okay, now coming to the next molecule, our longest chain will be this. Numbering from 1, 2, 3, 4 and 5. Okay, OH is again present at the second position, so I will write 2. How many carbon atoms? 5. Pentanol, OH, okay, just because of OH I'm writing ol. 1, 2 and 3. Longest chain is this. Ol is present at second position. 2, 3 in chemistry is basically propane. You can see that we write the whole name for the longest chain, like butane, pentane, propane, and just E is excluded, and all basically is replacing the E in case of alcohol's naming. Here our longest chain is here is this, and we can number it from both sides because OH is basically present in between both of these ends now, equally far from these ends, so we can number from here or here. I am starting from here. 1, 2, 3, 4 and 5. Okay, so OH is present at the third position, and I will write 3 dash, how many carbon atoms in the longest chain? 5. And in chemistry we use pentan for 5, and obviously ol at the end. Okay, now coming to the next molecule, our longest chain can be, it's quite tricky. Our longest chain, no, it's not tricky, it's quite easy. 1, 2, 3, 1, 2, 3, 1, 2, 3. I can select any one of them now. So I must select that carbon chain here in which OH is basically involved. I cannot select this 3 carbon atoms, but I should select these 3 carbon atoms because OH is directly attached. OH is basically a functional group, and a functional group must be involved in the longest carbon chain. So I will not select this part as my longest chain, but this portion. Obviously, both of these options have equal number of carbon atoms, but the preference will be given to that carbon chain which has the functional group. Okay, so I am using this as my longest chain, and I am going to number from here 1, 2, 3. Okay, now there are two things. Ol is present at first position, and there is a branch too, so I have to name the branch first, which is a methyl. Methyl is present at second position, so I will write 2 dash methyl dash. Ol is present at first position, so I will write 1. How many total carbons? 3, so I will write propane, and obviously ol at the end, so it's 1 propanol. Okay, now coming to the next molecule, I have my longest chain as this. Okay, this is my longest carbon chain. I can number from here because OH is really attached directly to this end, not from there. There is also a branch attached here, but the preference will be given to this end. 1, 2, 3. Okay, before going to the ol, I will name this branch first, as we did earlier. It's basically a chlorine atom, no? So a Cl, so I will use chloro. I will use O at the end of the halogen name. It is present at second position, 2 dash chloro dash. At first position ol is present, so 1, and ol is obviously used with the name of the longest chain now, so it's propane ol. So this is the method of naming the alcohols. Coming from name to the structures, we know that we first focus on the end part, which is prop, and I will write 3 carbons here, which are 1, 2, and 3. Okay, it's an ol, so obviously it's an alcohol, and ol is present at which position? Second position, so I will write this. Okay, it's quite easy. Now coming to the next molecule, it's pentane, so I will use 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. It's an alcohol again at second position, and 4 methyl means the methyl branch is present at the fourth position, so it will be our final structure. Now coming to the next, bute. 1, 2, 3, 4. 1, 2, 3, and 4, and it's an ol that is present. Okay, how many ol? Ol's position is not given here, so first of all, we coming to the branch 2,3-dihydroxy. 2,3-dihydroxy means 2 and 3 have 2 hydroxy, means this, and the position of ol is not given because there are 2 hydroxy and their positions are hydroxy basically means OH. Now there is a different name here in which the ol is represented as hydroxy here. Okay, this OH is basically of alcohol, this OH is basically called as hydroxy sometimes, so there is hydroxy is written as the alcohol. Ol is basically representing the alcohol molecule, and the positions of the alcohol's OH or hydroxy is given here. Okay, so there are 2 hydroxys, dihydroxy, at which positions? 2 and 3. So I have written at 2 and 3. Okay, and it's a butanol, so obviously 4 carbon atoms. Again, it's dihydroxy again, and hapt. First of all, we just make the longest chain, which hapt means 7. So 1 2 3 4 5 6 and 7. Okay, it's an ol again. Its position will be given here. 2 3 and dihydroxy. At second and third position I have 2 OHs. Okay, and that's it. Now coming to the next molecule. What is the, oh, it's a too long name, but just forget all this part. Just focus here. Prop. It's only 3 carbons, 1 2 and 3. It's an ol, and its position is given here at 1. So write OH here. Okay, we have done with this part. Now coming to the this part, 2-methyl. At second position we have CH3, or just write this single line, and 3-chloro. At third position we have a chlorine atom. So it's the complete molecules structure. Now coming to the last, 6-bromo-2-hexanol. Hexan means 6, so I will write 1 2 3 4 1 2 3 4 5 and 6, and it's an ol at second position, so I will write OH at second position, and 6-bromo, it means at sixth position I have a bromine atom, so I will add Br. Okay, at a halogen. A halogen will only represented as O at the last. Now bromo, chloro, fluoro, like this. So this is the criteria of naming the alcohols. Talking about aldehyde functional group, aldehyde and alcohol don't have that much difference, but there is a difference in the rule of naming the longest chain, which I will discuss later. But before it, understand this, aldehyde will be represented as CHO in any molecule, like this, CHO. Sometimes you will see CHO, or sometimes you will see like this, R, CO and H. Okay, sometimes you will see this type of the molecule, and sometimes like this. R is any longest chain or any type of chain. Now coming to the first molecule, but before this, first understand this one too, that we will use Al. In alcohol we used OL at the end of any alcohol's molecule's name, but this time we will use Al, and the numbering will be from CHO. Any type of molecule, any type of structure, but if you recognize that it's an aldehyde, then you will start the numbering from CHO. The CHO's carbon will be the highest priority carbon. Okay, that is the difference between an aldehyde and an alcohol's nomenclature. Okay, so you must select and the rule which will remain same here, that the functional group must be in the longest chain. Okay, now coming to the first molecule. In our first molecule we have this HCHO. What does it mean, HCHO? HCHO means there is HCHO. It is like this. I can write it like this as well. I can write this structure, this molecule like this as well. Okay, so I will number it, that how many carbons in this structure. Only 1 carbon atom, so there is no difficulty in selecting the longest chain. So it is only 1 carbon here, and we will name it. Obviously we know that in chemistry for 1 carbon we use a meth. Similarly, like alcohol, E will be eliminated or replaced by Al now. Okay, meth in al, it's a methanol. because of one carbon atom. If we talk about two carbon atoms, I will start numbering from there because it is a CHO. This is C, this is H, and this is O. So it's a functional group called aldehyde CHO. Similarly, CHO. There is another possibility for the confusion can arise. Like sometimes teachers not write H here. They actually write like this. They can actually write like this because H is obvious. Is an obvious thing. This is a carbon, and a carbon has 4 valencies. We know that one valency is occupied by a methyl group and 2 valencies are occupied by an oxygen group. So the last one will be obviously occupied by hydrogen. So they don't write hydrogen sometimes, so don't confuse it by this type of a structure. Remember, you can be given with a hydrogen or without a hydrogen. So it's a CHO as well, and this is a CHO as well. So we have 2 carbon atoms here, 1 and 2. So this time we have eth, N, and E is replaced by Al, ethanol. Okay, it's an ethanol. And if we talk about this structure, we have 3. So it's a propanol. You can ask me that why you are not mentioning the number of the functional group of aldehyde, that it's present at first position. So you must write 1 propanol, 1 ethanol, 1 methanol. You can write it. It's not wrong, but obviously in case of aldehyde, everybody knows that Al or aldehyde will always be at number 1 position. So we don't usually represent the aldehydes groups position. Okay, we don't mention the obvious things in chemistry. The second structure, or the next structure is like this. It looks like some complicated. It can be like this. I am writing it in a simpler form. 1 carbon atom and the other carbon atom is this, from which we have attached 3 chlorine atoms. So there are 2 carbon atoms basically. So we will write eth, N, Al, but there are 3 chlorine atoms as well. So we all know that the branches are named first. So there are 3 chlorines, so 3 chloros. Okay, there are 3 chloros here. So I will write trichloro, not 3 chloro. You know that when we are talking about the number of atoms, so we will write di, tri, and tetra. So it's trichloro. At which position? 2 position. I will write 2 3 times. Why? 2 for number 2 for each chloro atom. 2, 2, 2. Oh no space there. It will be like 2, 2, trichloro. I have named this branches. Now I can write the main name. 2, 2 trichloro ethanol. Okay, now coming to the next name. First of all, select your longest chain here because it's a branch something 1, 2, 3, 4. 1, 2, 3, 4. I can select any one of these, so I'm going to select this one. So numbering 1, 2, 3 and 4. I have a branch here, so I will have to name the branch first. 3 methyl. Methyl is present at the position number 3. So 3 methyl, and how many? 4 carbon atoms. So I will use a but, and obviously al at the end. Now coming to the next structure, which is this. I'm going to select my longest chain. 1, 2, 3. 1, 2, 3. 1, 2, 3. I can select any one of these. I am going to select this. Going to number 1, 2, 3. I have 2 branches at second position, so I will name them first. 2 methyls, no? There are 2 methyls. If it is if it will be like this, sorry, if it will be like this, so you will mention methyl and ethyl separately. It is composed of 2 carbon atoms and it is composed of only 1 carbon atom. Then you will write the name and position of ethyl first. It would be like 2 ethyl, 2 methyl, and then the main name. So I am going to name the methyls because there are 2 methyls, so I will write dimethyl. Their name is dimethyl, which is the position 2. 2 dimethyl. What is it? Prop 3 carbons, na? Prop. Achha, there will be no dash here, na? Because prop in all. 2 dimethyl propanol. Okay. Now coming to the next structure. It is quite complicated. We are going to select the longest chain. Students usually select this chain, na? 1, 2, 3, 4, 5, 6. But no, it's wrong. I can select a chain which has the functional group involved in it, which is this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. I can select this one. So I will select this one. Okay. Now as I have already told you that the highest priority group will be the CHO. So this is, sorry, it's an H. Okay, CHO. So I will number from 1, 2, 3, it's a branch, 4 and 5. Okay, and it's a branch 2. So I have 2 branches at 2 different positions. So ethyl comes first in alphabetical order. I will position and name this first. 2 ethyl. These are 2 carbons. It's an ethyl, and it's a methyl. 2 ethyl, 3 methyl, and what is the name of butanol? Butanol. Okay. Now coming to the next molecule. 1, 2, 3, 4, 5. I have 2 functional groups here. One is alkene and the second is an aldehyde. So for aldehyde we use al, and for alkene we use ene. Okay. So the method for naming these types of structures which have 2 functional groups in it, we try to name like, first of all, there are 2 or 3 methods of naming these type of structures. I am going to tell you this method according to your lecture. First of all, write the main name now, which is 5. So it's pent. Okay, dash, pent dash. What is the position of alkene? You will go for alkene first after the main name. 4 in dash. You then you can position the aldehyde. 1 al. It is the first method of naming the aldehyde and alkenes. I name them like this. There's another method like 4 pent. I will not use pentane. No. Usually we do this now, that we write the whole name and exclude only E from pentane. It is the usual name: pentane, alkane, methane, and we exclude this E and replace it by ol or al, etc. So here In case of alkene and aldehyde simultaneously, we can not use ane here. If you are going to name according to my method, then you will not use ane here, but you will use 4-pent, only pent, and then ene, because we are talking about the position of the alkene. 4-pent, ene, and then al. Okay, that is my method, and that is your lecture's method. So that's all about aldehydes. Let's start making the structure of aldehydes. The names are given here. First of all, start from this structure, propanol. Propanol, as we know that going from structure to the going from names to the structure, we first focus on this type of alkanes names, no? So it's a prop. So I will write 3 carbons here, 1, 2 and 3, and it's an al, and obviously as we know that al represents aldehyde, and in case of aldehyde we don't represent its functional group position, and it always be at position number 1. So it's an obvious thing that aldehyde's functional group will be at position number 1. So I will make this position number 1 as an aldehyde. It's a carbon number 1 and it's an aldehyde. I can write this structure as this as well, CHO. It's carbon number 1, 2 and 3. It's a propanol. It's a propanol 2. Now coming to the 2-chloropropanol. It's a prop again, so I will write 3 carbons here. Okay, it's an aldehyde, and aldehyde's position obviously not represented anywhere, so it will be obviously an aldehyde functional group at position number 1, and 2-chloro, so 2-chloro. Okay.